some area or something like this. So the concept is very close to that. So in that case, integration I is nothing but the summation of integration of x0 to x0 plus nh f of x dx. Okay, so this is a function. You will integrate this function within the range x0 to x1, then you will get the value, total summation of the value. Okay, and as I stated earlier, we will use the interpolation formula developed earlier in the integration. So you need to replace the function and as well, because in interpolation formula, if I recall from last classes, the interpolation formula is actually represented in terms of p. Okay, like this interpolation formulas, like look at this equation. The interpolation formulas are always represented in terms of p. So p is nothing but, for forward interpolation, this is nothing but the x minus x0 divided by h. That means this is another variable. So your equation must be changed, and corresponding limit, sorry, this is x0. Okay, the corresponding limits will also be changed. So in this equation we should put x is equal to x0 plus ph. Okay, because we know that p is equal to x minus x0 divided by s. So if you just turn to this, now dx will be x0, as it is a constant, this is 0 plus you will get here h is also constant, and p, that means if you take the differentiation, dx is equal to h dp. Okay, so you will get dx is equal to h dp. So now change the integration, change the total integration formula. After rearranging, you will find h, as it is constant, it will come closer, 0 to n, and x0 plus n, and function of x0 plus ph dp. Okay, actually this x0 plus ph, this is actually nothing but y. Okay, 0 to n, this function is actually nothing but 0 to n yp of dp. Okay, so after summarizing, you will find I is equal to integration 0 to n, here you will going to multiply it by h yp dp. Okay, so in this case, at this stage, yp is again the say, if you consider the Newton's forward interpolation formula, if you go back to previous 2 or 3 class, this is very well known to all of you, Newton's forward interpolation. In that, the formula was yp is equal to y0 plus p del y0 plus p into p minus 1 by 2 factorial del square y0. In last class, maybe also starts from this for the numerical differentiation also. So the equation is, there is nothing new, 3 factorial del cube y0 plus go on. So this is your yp, this is the function. So if we integrate this function h constant, if we integrate this function 0 to n limit, okay, this is your total function dp. So you will get total I value. Okay, total integrated value, that means h will be constant. Just wait. Okay. So the total integrated value you will find after integration like this h. If you y0 is a constant terms, and if you take the integration 0 to n limit, and you will get n y0 plus p del y. So if you need to change the limit, so after changing you will get the n square by 2 del y0 plus half of um, n cube by 3 minus n square by 2 del square y0 plus so on. So this is with respect to n, and this equation is known as Newton Cotes quadratic formula, quadrature formula. Actually, these equations you never need to memorize this. I am just showing you how the numerical integration formulas are developed. So just have a look on these equations. And in numerical integration, we actually cover a few methods. The first method we will cover is the trapezoidal rule. The trapezoidal rule, and then we will cover also the Simpson 1/3 rule, Simpson 3/8 rules, and Weddle's rules. These four equation. So the all of these equations are actually starts from Newton Cotes quadratic formula. So in these formulas, for trapezoidal rule, so very fast step, for trapezoidal rule, we will put n is equal to 1 in this equation. We will put n is equal to 1. So if you put n is equal to 1 and neglecting the second and higher order, that means these orders, higher orders, if you neglect, put n is equal to 1 and neglect second to higher orders. So you will get only the single integration, that means 0 to x0 to, the first integration will be x0 to x0 plus h f of x dx. That means only n is equal to 1, that means x0 to h, x0 plus h. So in that case, if you take n is equal to 1, put here n is equal to 1, you will get h y0 plus half of del y0. Okay, you will get this. So we know del y0 is nothing but half of del y0, this is nothing but y1 minus y0. Okay, you know this while forming the difference table. You did complete this step. So after simplifying, you will get here y0 and y1, you will get here h by 2 y0 plus y1. Okay, similarly, if you go for next step, that means now we are going entering the integration process. That means x0 to h1, x1 first step, x1 to x2 second step, single segment. That means we will here cover the individual segment 2, 3, 4, 5, and up to n. That means we will get some individual segments, and while we will join all these segments, taking the numerical summation, this total result will be your numerical integration results as per trapezoidal rule. Okay, so similarly you will get x0 plus h2, x0 plus twice h for second step, f of x dx. So in the similar manner, you will find x0, y0 plus y1. Here you will find y1 plus y2. Okay, because actually x0 plus h, this is x1, x0 plus 2h, this is x2. Okay, and it will continue up to x0 plus n minus 1 h, n minus 1 f of x dx up to x0 plus nh. And in this case, you will find x0 by 2 y n minus 1 plus yn. So taking the all the summation, that means x0 to x0 plus nh, you will f of x dx. That means total integration value you will get here. Look at like this, x0 plus 2, and while taking all these value, that means y0, y1, y1 plus y2. So one thing this equation is I think known to you in surveying. That means y0 is single times, yn is single times. So we write like this, y0 plus yn, these are the single times, plus 2 into y1 plus y2 up to yn minus 1. Okay. So this is the this rules is known as the trapezoidal rule. Okay. In this equation, look at this. While you're taking the numerical integration, all things are known. Y0, yn, y2, all of these are the uh, coefficient of y in the table, and h is the equal interval. So all these things are known to you. So this is very simple. And the second method, that one is, you just need to remember the these equations, the formulas for or individual rules. Simpsons 1/3 rules. I think this Simpson 1/3 rules is also known to you in surveying. So in Simpson 1/3 rules, we actually take n is equal to 2. Okay, n is equal to 2, and if we take n is equal to 2, we will neglect third or higher. So take n is equal to 2 and neglect third or higher order. This will actually give you for the first, as n is equal to 2. So this step, at this case, these steps will be x0 to x0 plus twice s. Okay, f of x dx. That means in this case we actually considering two steps. That means here actually I just want to remove something, so it will be easier for all of you to remember. In this case actually we consider two strips at a time. That means x0 to x2. Okay, x plus 2s up to this. So at first step you will adding these two steps and then another two strip like this. Okay, that means we are expanding our range of summation, x0 to 2s. So after simplifying, if you put this, you will get s by 3 y0 plus 4y1 plus y2. Okay, so these are actually as this is h by 3, so this is known as the Simpsons 1/3 rules. And next step you will take x0 plus 2h to 4h, that means x2 to x4. So after adding all these terms, x0 to nh, that means up to nth term, you just remember the equation, for which equation how it works. The first term is y0 plus yn, this is constant, plus 4 multiplied by odd terms, that means y1, y3, yn minus 1, that means odd terms, plus 2 into y2 plus y4 plus yn minus 2. Okay, so for Simpson 1/3 rules, the total summation is actually h by 3, first y value of first set, first plus last set, plus 4 multiplied by odd values y1, y3 and so on, plus 2 multiplied by even values. Okay, so this equation is Simpson's 1/3 rules. And next one, that's the Simpson's 3/8 rules. Okay, for Simpson 3/8 rules, we actually consider n is equal to 3. That means in each steps, each increment, you will start in like x0, first integration will be x0 to x0 plus 3h, and next step 3h to 2 plus 6h. Okay, that means n is equal to 3 for each terms, and we will neglect the third order above. So for this case you will get x0 plus 3h f of x ds. This summation will be nothing but 3 by 8 of h multiplied by y0 plus 3y1 plus 3y2 plus y3. Okay, like this. So after adding all the terms, the total integration value I will be so if you take the total integration x0 to x0 plus nh f of x dx, this will give you 3 by 8 of h plus y0 plus yn plus 3 of y1 plus y2 plus y4 plus y5 plus y7 up to yn minus 1, and plus 2 of y3 plus y6 plus y9. So you need to remember this equation up to yn minus 3. So look at this again. The first terms is the y0 plus yn, then y1, y2. Only missing terms are the y3. That means multiplies of 3, y3, y6, y9, so on. These will be multiplied by 2, and the remainings will be multiplied by 3. So this is the Simpson 3/8 rules. And the last rules, that's the Weddle's rule. In this method, we will take n is equal to 6. In Weddle rules actually cover n is equal to 6. Okay.
স্যার এখানে ওই যে আগের লাইনে ওইটাই y3 plus y6 এর আগে এটা কি 2 না 3?
2. This is 3. Okay. Clear?
স্যার তাহলে কি এখানেও 3 হতো না, মানে i equal to যে লাইনটা লিখেছেন
3 multiplied by y1, y2. In this y3 actually this is the first terms. So if you take another term, the next one x0 to x0 plus 3 to like this. Take this x0 plus 3h to x0 plus 6h. Okay, and the successive this will go up to x0 plus n minus 3h to n plus h, last term. So while adding all these, after taking the summation, and you will get in this form. Okay, first term plus last term plus 3 multiplied by y1, y2, so up to yn plus 1. Only the missing terms will be y3, y6 and y9, and for these values y3, y6 and y9 you will get 2. Okay.
Okay,
because here only one y3, and the next part you will get another. If I write this, the next
জি স্যার মানে আগেরটা অ্যাড করলে আরেকটা y3 আসে
y3
ওটা বুঝতে পেরেছি স্যার।
থ্যাংক ইউ স্যার। Okay, so in Weddle's rules we actually take n is equal to 6, and taking the higher orders been neglected. So actually, okay, just up to today's class only consider these 3 rules. I think Weddle rules we may discuss in next class. So now we will take an example to explain all these 3 methods actually. Okay, so we'll close our today's class with an example to explain how we can apply these 3 rules. So let's consider the velocity the velocity of a particle at distance s from a point on its path given. So here you will find a tabular data like this, distance versus velocity in feet unit. This is distance and the velocity feet per second. Okay, this is your data. So if we measure the velocity of the particle after every 10 feet distance, okay, at every 10 feet interval we are recording the data 30, 40, 50 up to 60. So this may be 47, 58, 64, 65, 61, 52 and 38. So this is your data. That means for this specific problems we are actually recording the velocity of a particle while it's moving on its path after a certain interval of 10 feet. So this is your recorded data or observed data. So now if I ask to estimate the time required to travel 60 feet distance. Okay. So I may ask you to what will be the time to travel particles from 0 to 60. So that means total length, how time it will take. So and these can be done by using different method. That means the integration methods actually. So we will solve this using the Simpson 1/3, Simpson 3 by 3/8 rules, and as well as the trapezoidal rules. And then you may compare with the different methods. Okay, in which methods the accuracy or the results variation of results, you may also find this. So let's first start the basic principle. We know that velocity of a particle actually in the derivative forms, this is ds by dt. Okay, change in distance with respect to time. So this is ds by dt. So here my required condition is dt. That means I need to estimate the total time dt. This is nothing but v ds. Okay, so if you want to calculate, sorry, this I may write in wrong format.
So 1 by
Actually
v.
this is actually 1 by v of ds. So if you want to calculate the total, okay, total time, that means you need to integrate and within a range. That means total time t will be integration of 1 by v ds within, that means ds s limit will be 0 to 60. And if you ask to what will be the time up to 40 feet, that means the particles taken the time to reach in 40 feet. So in that case you will take, just change the limit, you will start 0 to 40. Okay, so in this case now consider another terms 1 by v, that means 1 by v ds. Okay, so uh, actually if we represent in another form like this, take this as a y, okay, and s, this as a x. So what will become 0 to 60 x y dx. Okay, actually y dx. Okay, so if you represent this as a y, so you need to calculate, I am just removing some part. Okay, copy this one. if we can start from the given data, this will actually, sorry, actually done. So this is your given data. In this case, for the integration purpose, I considering y is equal to 1 by v. So for all the data set, just take 1 by v. Okay, so your 1 by v is equal to y. So I am taking the inverse value of all these. That means you will find like this: 0.0212, then 0.01724, and so on. And corresponding as this is actually your x. Okay, so if you go for our conventional xy coordinate system, these are the actually in integration from this, these are the 0, x0, x1, x2, x3, and x6, and corresponding y value. So this is your y0, y1, y2, y3, and y6. Okay, so you have actually in at this stage of problem, after simplification, you have the values of x0 to x6 and corresponding y0 to y6. So and the form is integration of y dx. That means the total time I, this is actually integration of 0 to 60 within x0 to x6 y dx. So if you apply Simpsons 1/3, Simpsons 1/3, okay, apply for Simpsons 1/3, integration of y dx 0 to 60. The rules was h by 3 y0 plus y6. That means yn. Here actually our last term is 6, so y0 plus y6 plus 2 of y2 plus y4, 4 of y1 plus y3 plus y5. Okay, because as the rules, the equation was Simpson 1/3. Okay, like this: first terms plus last terms plus summation of odd terms. That means y1 y3 up to n minus 1 multiplied by 4, even term multiplied by 2. So we just writing this equation as here we have only 6 terms. So first term plus last y ordinate values, and after putting all these value, actually these y1 y3, this is nothing but the inverse of v. Actually y is equal to 1 by v. So if you simply take inverse of all of these, 0 to 63157, these are very simple. And after you putting all this value h, so what is the h value in this case? 0, 10, 20. So h is equal to 10. Okay, this is also known. So after putting all this value, you will get 1.063518. Okay, so the another question, what's the unit? 1.0635. So what will be the unit in this case? For these problems, look at this: the distance are given in the feet and velocity in feet per second. So this is obviously second. Again, and if you complete comparing the results for the Simpson 3/8 rules, so for Simpson 3/8. For Simpson 3/8, the equation is actually 0 to 60 y dx. The equation will be 3h by 8 y0 plus y6. That means first plus last, plus 3 multiplies by other values. That means y1, y2, y4, and 2 multiplies by actually 3 plus as we have a total 6 terms, so y6 this will not be here, this will goes to the as the first term. So just remove this y0 and y4 up to y5. So this is your equation. Again, all the values are known, h values known, all the y coordinates are known. After putting all these value, take the summation, you will get 1.0643723. That means 1.064 second. Okay. So this we solve the same problems in two methods, and there may be so up to this the I think the numerical integration this is a very easy process, and we will today we learn three methods, and again you may also follow the trapezoidal rules. So for trapezoidal rules, the rules is here: h by 2, first term plus last terms plus 2 multiplied by other terms. That means, and here as we have 6 number of set of data or 7 number of set up to y6, so y0 plus y6 plus 2 multiplied by other y values, summation of other y values. So you may also try the trapezoidal rules, and may check your results in trapezoidal rules with respect to Simpson 1/3 and 3/8, or may compare what will be the variations in the estimated results. So this is the application of numerical integration methods. And the another some other types of problems, like while if a curve, okay, say for a curve or circle or any types of curve is passing from few points. So if you take the simply some few points like this, where I'm shown arithmetical form in here. So if you ask to calculate the total area, that means total area covered by this curve, so you can simply take the summation, and this can also be done by numerical integration. And you may found some workout example and exercise in your books. So I am suggesting all of you to do some homeworks, like the similar problems you may try in try yourself. And again we may also try some integration problems, like integration 0 to 10 dx divided by 1 by 1 plus x squared dx. Okay, in these types of integration you may found in your math courses in also in level 1 also. So for such types of integrations, we simply follow the rules of integrations. Instead of following the normal calculus, we may also try this in the numerical method. Okay, so here my question may arise, okay sir, there is no specific x and y set of data, so how may we apply? Okay, so for these types of equation, actually you may consider this portion as y. Okay, integration 0 to 10 y dx. Okay, so for this this y, this is actually y is equal to 1 plus x square. So what will be a set of data? Now you can consider, and you need to generate your xy data. Okay, you need to generate the xy data. Suppose x is equal to 0, 1, 2. As your limit is 0 to 10, so here we are considering h is equal to 1. That means 0, 1, 2, 1 increment up to going, it will go up to 10. Okay, 3, 4, 5, 9, 10, up to 10. And if you put x is equal to 0, you will get y is equal to 1. If you put x is equal to 1, you will get 0 0.5, and then you will get 0 0.2, 0 0.1, and so on. So this is your set of data you may generate manually. You may generate, and one may consider, okay, I am not going for so many data. I will take h is equal to 2. In that case, you will get 0, 2, 4, 6, 8, 10 less number of set of data. So you will you can easily generate this set of data, and then you go for our conventional numerical integration process by any methods. That means you have the y values. This is actually y1, y2 up to y10. Okay, so after finding all this data, uh, you have the age values and y values. In numerical integration, we only need the corresponding y ordinates, that means y values from the data set, and the h values, that means equal increment of h, x value. And after collecting all this data, you simply follow any rules, and may Weddell's rules, Simpson 1/3, Simpson 3/8, or Trapezoidal, anyone, and you will get the total integration values. Again, you may also check these integration problems with the with your calculator, or may also check in manually. So you may compare with the actual result and numerically projected results. That means in numerical method there may be some problems, or there may be some errors. So it's obviously vary from the actual one. So if you are interested, you may also check this one also. So what will be the actual calculus result from this for these integrations, and what's the numerically projected values in different methods. Okay, so I think today's class is are for these topics, and at this stage we are completing the numerical integration and numerical differentiation also. So if anyone have any question, the floor is now open. So if anyone have any question, you may ask, or I will upload the recorded lives as well as the lecture materials to your classroom. And last class, someone may ask that some previous lectures are not showing. Actually, those lectures are transferred to the Metras. So I restored all the video lectures, and anyone please have check and let me know if still they have any problem or not. Okay, so I think I can close the class as no one have any question.
Sir,
Okay,
hello.
বলো।
স্যার ক্লাস টেস্টের ব্যাপারে স্যার কিছু বলুন।
আচ্ছা, ক্লাস টেস্টটা আমি খুব সম্ভবত নেক্সট ওয়েডনেসডে ডেট দিয়েছিলাম, তাই না?
স্যার থার্সডে নিয়ম স্যার।
আচ্ছা, থার্সডে নিলাম, সমস্যা নাই। ক্লাস টেস্টটা অ্যাকচুয়ালি আমি অ্যাসাইনমেন্ট টাইপেরই দিব। তোমাদের যেহেতু এখন চিন্তা করতেছি, আমি ইন্টিগ্রেটেড একটা প্রবলেম দিব তোমাদেরকে, তো এটা তোমাদেরকে করতে হবে। অ্যাকচুয়ালি ক্লাস টেস্ট আমি অ্যাসাইনমেন্ট টাইপেরই দিব, যেহেতু ম্যাথমেটিক্স একটা সার্টেন টাইমে ক্লাস টেস্ট দেওয়া সবার কাছে হয়তো বা ক্যালকুলেটর নাই, সো এটা একটু ডিফিকাল্ট হবে। একটা সার্টেন বা টাইমটা খুবই শর্ট থাকবে, বৃহস্পতিবার দিলেও শুক্র শনিবার আছে, হ্যাঁ, অফ ডে এর মধ্যেই তোমাদেরকে আমি দিব। তো তোমাদেরকে যেটা করতে হবে, হয়তোবা ডাটাগুলো ভেরিয়েবল থাকবে, মেথড ভেরিয়েবল থাকবে, প্রবলেমের একই ডাটাতে এক একজনকে এক এক ধরনের দেওয়া থাকবে। দ্যাট মিনস এটা অনেকটা ওপেন বুক, তো তোমরা তো অ্যাসাইনমেন্ট করতেই পারবা। জাস্ট একটু মেথডগুলো বুঝে ক্যালকুলেশনগুলো নিজে করে দেন হচ্ছে প্রবলেমগুলো সলভ করে আমাকে দিবা।
টপিকটা কি স্যার নিউমেরিক্যাল ইন্টারপোলেশন ওইটা নাকি স্যার?
হ্যাঁ, টপিক আমি নিউমেরিক্যাল ইন্টারপোলেশনই দিব। ইন্টারপোলেশন ইভেন আনইভেন টোটাল নিউমেরিক্যাল ইন্টারপোলেশন যে টার্মটা টপিকটা ওইটাই আমি দিব, এবং আমি তোমাদেরকে অ্যাসাইনমেন্টের জন্য দিয়ে দিব আর কি। ঠিক আছে?
ওকে স্যার।
আচ্ছা, ঠিক আছে, আমি টোটাল ডিটেইলস গাইডলাইন সবই দিব, সমস্যা নেই, আশা করি বুঝতে পারবা। আর নেক্সট ক্লাসে দেওয়ার সময় আমি বুঝিয়ে দিব। ঠিক আছে?
জি স্যার, থ্যাংক ইউ স্যার।
ওকে।